Every year on the AP Chemistry exam, question number 4 on the free response section is all about reactions. You have to write out the reaction, you have to balance the reaction, and then there's some follow-up questions about that. So the next unit that we're going to start is all about question number 4. So you can call this unit if you would like question number 4, but it's all about reactions. Last year you should have learned some basic types of reactions. Synthesis is the simplest one. Synthesis is two things making one. So for example, A plus B produces AB. Or mercury plus oxygen produces mercury 1 oxide. So what I would like you to do next is take your homework assignment, find the slide that says synthesis, and it should say solid calcium oxide is exposed to a stream of carbon dioxide gas. And on the right hand side you should have some lines there. I want you to write out the reaction and balance it. You're going to have to predict what the product is. If you need to pause this video, please do so now. The next type of reaction is decomposition, which is the opposite of synthesis. Notice we have AB breaking down into A plus B. There's a couple keys on this. Always look for some sort of gas to be given off. Okay? For example, right here, I kind of see oxygen gas being given off. Down here, I see carbon dioxide gas given off. This one's actually going to give gaseous water off. Down here again, we're giving off oxygen. Here are some rules that you have to have memorized for decomposition. Metallic oxides, when heated, always break down into a metal and oxygen gas. Metallic carbonates, when heated, decompose into metallic oxides and carbon dioxide gas. Metallic hydroxides, when heated, decompose into metallic oxides and water. Metallic chlorates always break down into metallic chlorides and oxygen gas. This is the reaction that we did with the gummy bear demonstration. And then there's a couple acids that are so weak that they constantly break down. Carbonic acid always breaks down into carbon dioxide and water. Sulfurous acid always breaks down into sulfur dioxide and water. So if you look at your homework once again, it says solid magnesium carbonate is heated. I want you to write out the reaction and balance it. Single replacement. Single replacement I always like to think of is a boy and a couple, and you're simply switching the boys. It could also be a girl and a couple, and you're switching the girls. A cation will replace another cation. Cations are positive ions. An anion will replace another anion. So for example, down here we've got sodium plus water. Now another way to write water is HOH. So sodium is trying to replace hydrogen, and it's going to end up replacing hydrogen and producing sodium hydroxide. And then hydrogen will be all by itself. And of course hydrogen by itself is H2 because it's diatomic. Okay. On your homework, chlorine gas is bubbled into a solution of sodium bromide. This is a single replacement reaction. Write out the reaction and balance it. Double replacement. I like to think of double replacement as two couples going to prom, and you simply switch the boys or switch the girls, whatever you want. In order for a double replacement to take place, the products must produce either a gas, a molecule, or a precipitate. Every single reaction in question number 4 is a reaction that will take place, so you'll never have to worry if it's a no reaction or not. So here we have hydrochloric acid plus sodium hydroxide, and we're going to switch the boys. Okay, so sodium is going to hook up with chlorine, sodium chloride. Hydrogen is going to hook up with hydroxide to produce water. Water is a molecule, so therefore this reaction does take place. Here we've got lead 2 chloride plus sodium sulfate. The boys are going to switch, so lead is going to hook up with sulfate over here. Sodium is going to hook up with chlorine over here, sodium chloride and lead sulfate. Lead sulfate is a precipitate, therefore this reaction does take place. If you produce carbonic acid or sulfurous acid as one of the products on this side, don't forget that is such a weak acid it breaks down. So in this one, sodium carbonate plus hydrochloric acid, sodium is going to hook up with chlorine, sodium chloride. Hydrogen is going to hook up with carbonate to produce carbonic acid, which breaks down into CO2 and H2O. Neutralization reactions, such as this one right here, is an acid and a base. An acid and a base always produces some sort of salt. A salt is an ionic compound, and water. Okay. Go ahead and try the next three types of reactions. They're all double replacement. Two couples going to prom, switch the dates. Solutions of silver nitrate and sodium chromate are mixed. Hydrogen sulfide gas is bubbled through excess potassium hydroxide. And a solution of stannous sulfate is added to a solution of ferric sulfate. Anhydrides, I doubt you learned last year, so this one's going to be new for you, but it's pretty simplistic. Metallic oxides, this is a metal, sodium is a metal, so metallic oxides plus water always form a base. So sodium oxide plus water produces sodium hydroxide. Non-metallic oxides plus water always form an acid. Sulfur trioxide plus water produces sulfuric acid. The nonmetal maintains its oxidation number. There's going to be a video coming up soon on oxidation numbers. We'll get to that later. So with that in mind, for anhydrides, try both of these. There's two reactions here. Solid potassium oxide is added to water. Solid dinitrogen pentoxide is added. That should say to water. To water. There we go. And finally, the last one, combustion. Anytime you burn something in the presence of oxygen, it's called combustion. Yes, I know this right here is synthesis. It's also considered a combustion reaction. Magnesium is heated in the presence of oxygen gas. You're going to produce magnesium oxide. Combustion of a hydrocarbon, and you guys learned what hydrocarbons are during the organic chemistry unit that we did, will always produce carbon dioxide and water. So that doesn't mean that up here, if I'm burning magnesium with oxygen, you should not have carbon dioxide and water over here. Okay? First of all, there's no carbon over here. There's no hydrogen over here. You cannot produce carbon dioxide and water. That's only when you burn a hydrocarbon. So, please try this one. Ethanol is burned in oxygen, and you guys should know what ethanol is.